Hey guys, and welcome to this presentation on motion, which is P2.1. So for motion, you have to know the basic formulas: distance, speed times time, displacement, velocity times time. And then you also have to know the difference between vectors and scalars. And basically, a vector includes a direction as well as the magnitude. So that means that you can have positive and negative values, as usually there will be a positive direction and a negative direction. So for example, if you throw a ball up in the air, for the first part where it's travelling upwards, that could be the positive direction. And then when it comes back down, that's negative. So the velocity will actually be negative because it's going in the negative direction. And then acceleration is change in velocity. So it's change in velocity divided by time. And it's measured in meters per second per second. So this is a distance time graph, and you can calculate speed from a distance time graph, which is you calculate the change in distance represented by the green line, and that's 6,000 minus 3,000, which is 3,000. Then change in time, 250 minus 125, which is 125. And then since we know distance divided by time is speed, you do 3,000 divided by 125, and that results in 24 meters per second. And we know this is meters per second because they were the units used for distance and time. If it had been miles and hours, the answer would have been in miles per hour. And then you can also have displacement time graphs, which have you can have a negative gradient on them. Say you go out somewhere and then you return back to the starting point. The starting point is going to be 0. So when you're returning, it will be decreasing. You can even go into negative figures. If, say, you go 1 kilometre north, which is positive, then 2 kilometres south, that second kilometre south will be negative. Finding velocity, you just do the same thing as finding speed. But obviously, if it's a negative gradient, you will be expecting to get a negative displacement. So you can also have velocity time graphs, which is, so basically velocity time graphs, since they have time on the x-axis, it shows you the rate of change with time. And we know that change in velocity over time is acceleration. So therefore, you can calculate acceleration from velocity time graphs. So you do it the same way as calculating speed and distance time. For example, if you wanted to calculate velocity between A and B on the top diagram, it would be 7 minus 0, which is 7, divided by 10 minus 0. So it would be 0.7 meters per second acceleration. And then between C and D, you would have to do 0 minus 7, since D is the value that is at a larger time. And then you do 50 divided by 30, so you would get negative 0.35 meters per second, which is also called deceleration. And then in the second diagram, acceleration would be negative throughout, but there's still more forwards movement at the start, since velocity is positive at the start. So equations for motion and energy. You have the equation for motion is v squared minus u squared is 2as, and that equation is given to you in GCSE, so you only have to be able to apply it. And then there's the equation for kinetic energy, which kinetic energy is half times mass times velocity squared. And that one you do have to remember for GCSEs. Both of these equations can be rearranged to make any of the values the subject. And so therefore you can find out any of these values if you have all the other values in the equation. Thanks for watching. Bye.